Let's try numbers 14 and 15 real quick. In section 3.2, these are not with the limit definition. These are using our derivative rules. Should be familiar with the power rule. All right. Derivative with respect to x, that's what this d over dx means. Take the derivative with respect to x. And this is the function we're taking the derivative of. Here, n is a constant. So x is the variable, x to some constant. Derivative is n times x to the n minus 1. Kind of bring the constant down in front, subtract 1 from the exponent. Okay, then we have the rule for the derivative of e to the x, which is real easy. The derivative of the function e to the x is e to the x. Excuse me. Easiest rule in the book. Okay, now take the derivative of this function here. We've got the difference of two functions. So derivative of 7 e to the x, 7 is a constant multiple pulled out. What's the derivative of e to the x? Easy rule, right? 7 e to the x. Minus, pull that 6 out. What's the derivative of x to the fourth? Power rule, right? Bring the 4 down, subtract 1 from the power, left with 3. Clean this up, 6 times 4, 24. There's the derivative. Real easy. This next one, I'm going to include the constant rule, right? For c being any constant, the derivative of any constant is 0. And so here's what we're taking the derivative of in number 15. So the derivative of 1, which is a constant, is 0. Minus 12 is a constant multiple, pull it out. What's x to the 1/3? Power rule, bring the 1/3 down, x to the subtract 1 from 1/3, negative 2/3. What's the derivative of 5 e to the x? 5 is a constant multiple, pull it out. What's the derivative of e to the x? E to the x, 5 times e to the x. Derivative is the same. Clean this up. I get negative 12 times 1/3 is negative 4, x to the negative 2/3 plus 5 e to the x. So two simple derivatives. Hopefully you're practicing a lot of this and getting used to things using these rules for derivatives.